we go. Hello. So my name's Terry Schussler. I'm the Senior Director of Spatial Computing working in the 5G group at Deutsche Telekom. And I'm a big believer in using the technology that I talk about. So I'm going to be using AR in two ways today. One is going to be speaker notes for myself using these very cool magenta-colored Vuzix Blade glasses. And of course, you're going to see augmented reality content. So I like to believe that we will eventually start eating our own dog food, if you will, and I'm trying to prove that point. So today, I want to start by talking a little bit about where we're at with society, and particularly in our use of mobile phones. I believe that we are now in the middle of a mobile zombie apocalypse. And you can see this today because we're a slave to our phone. We're a slave to the computer technology that we use every day. In fact, if some people who play Pokemon Go are actually being ridden by the Pokemon. We have a world where people are so focused on doing selfies and using augmented reality in a very narcissistic way. They're walking down the street in a major city. 50% of the people are looking at their phone and not where they're walking. It's almost like we have radars. It is a problem. And part of what I'm passionate about is figuring out how we can leverage technology to improve the life of everyday users by moving us away from a heads-down society and back to a heads-up society. So, the main goals that I have is to increase real-world social experiences. Venues like this, where people get together and talk and communicate, these are very important to me. And I want to be able to use the technology that I enjoy off of my mobile connected phone, but I don't want it to be in place of the real-world interactions that I have. We want to increase the engagement with real-life experiences. We have a limited time on this planet. When you go out and do things that are important in the real world, traveling, on vacation, having business meetings with colleagues, you want to make those experiences richer and deeper and not less engaged. We don't want to be distracted by our mobile phones when we're walking around traveling. We want to enjoy the beautiful environments that we're in. And of course, I also feel that getting the mobile phone back into our pocket as much as possible and out of our hands, creating a hands-free experience, and one that's also tactile, using technologies, haptics technologies, wearables that provide different kinds of feedback to you, is also an important goal that I have. So, one thing that's very important to keep in mind is that the real-world field of view that we get through looking at content through a mobile phone is about 5% of what you would have in the real world with our normal visual perception. And this is a real problem. So, it's really important to me that we think about the idea of human safety and how can we take head-worn AR experiences and head-worn AR technology and enable users to have a safer world. So one of the things that I'm going to have as a thread in my conversation that I want you to be thinking about is how do we take advantage of 5G and edge compute and various types of devices to enable a safer human experience. So to accelerate adoption of XR or head-worn devices, we first need to show users what good looks like. And I like to tell a story about my children when they were young. When I would go and ask them to clean their bedroom, they would do what they thought was the right thing to do. And then they would come back and say, okay, Dad, I cleaned the bedroom. And I would go back into the bedroom and I would look and everything was a mess everywhere. They would take all the dirty clothes and stick them in a pile in the corner, and the books would be all over the place and stuffed under the bed, always lots of things under the bed. And so I decided one day that I needed to help them understand what I meant when I said to do it right. So I did clean the room with them. And then when we were done, I took a picture of the clean room. And I printed it, and I stuck it on the wall in their bedroom. And I said, the next time I ask you to clean your room, that's what it should look like. That's what good looks like. So I think as we develop user experiences using the technology stacks of 5G and edge compute and build XR experiences, I think it's really important that we show users what good looks like. And I think to be successful, we need to move away from the very vertical very time-limited use cases that we're used to doing today because they're easy to build profitable business on top of, and start tackling some of the harder problems, some of the most important things is to create adoption and accelerate that adoption is to build use cases that are more time durative. So instead of using the Pokemon Go app and turning AR on for 30 seconds while you take a picture of a selfie with a Pokemon sitting in some weird place, we want to build an experience that is adding value to what you're doing in the real world for a lengthy period of time, 1 to 3 hours. So you go to a football game and you're watching the players on the pitch, and when you're wearing your AR glasses, you can see statistics and get details and order beer to your seat and add value while you're still high-fiving your friends and shouting for your team and so forth. These kinds of experiences, I think, are going to really create traction because they are, in my mind, very similar to what happened when Lotus 123 as a spreadsheet product came out in the early 80s. It was so powerful of a tool that people bought IBM PCs. For over a year and a half, it was the #1 driver of IBM PC sales, and it created an acceleration inflection point in the industry. So I think it's very important for us to look at doing that with use cases that have more time durative, more comprehensive experience. The second is to focus a lot on that first-time user experience. I think a seminal moment occurred when the Oculus Quest came out because it changed the way the user experience that UBI, the out-of-box experience. Now, having a really good UBI is very important. So when you use Oculus Quest, the entire unboxing and first-time user experience is a gamified, fun, and clearly identified experience. And I think that it's important as we build apps in a world where we no longer write documentation, don't even have help systems, and the most instructions you get are 5 screens that you see the first time you run the app, and then they're gone and you never have them again, is to really focus on getting that first-time experience right. Showing users what a good experience is like in one app will help you communicate the value of the next app. And then focusing on things that matter. So building user experiences that really transform the way people are spending their time to make it richer. Experiences when you are traveling in a new city that show you points of interest in an interesting and personalized and contextualized way. Translate signs from a foreign language to their native language. Help them find the things that are of interest and have the surprise discoverables while they're still focusing with their normal human vision on the real world and they're using their hands to touch and see things. So it's very important. I also think that if we want to focus on building a more pervasive experience, we need to really focus in on the user a lot more, on the needs of the individual user. So my vision for where we're going to need to go in terms of building an always-on, all-day wearable XR head-worn device experience is that we have to think not in terms of apps, but in terms of people. So I'm not going to be launching apps in the future. I'm going to put my glasses on and they're going to turn on. And an ecosystem of services are going to collaboratively work together to present just the right pieces of information at the right time in the way that I prefer, using the technology services of the vendors that I like the most. So when I want visual directions when I'm driving a car, I might like the style of Waze. I want the Waze traffic display or navigation display service. I don't need the whole app. I don't need all the functionalities. I just need and want the specific services that are built into those apps. So we're going to have to think entirely differently about how we build applications and how we deploy the compute tasks of those applications. And this is where 5G and edge compute will really provide a lot of value, and I'll talk about that in a moment. Also, we have to personalize and contextualize and really understand the user and give the user what they need, what they want, the way they want it. And so this involves thinking differently about how applications are built. Because today, if I build 2 separate applications on a traditional OS, I can't have those, like iOS or Android, I can't easily have those applications share data in real time with each other. It's a very sandboxed world. And in the future, these application services are going to have to work together fluidly and collaboratively. I'm going to have one large application that runs the entire experience for me from the moment I turn it on to the time I turn it off. I like to think of spatial computing as acting as the user experience for AI. So we're going to have a lot more use of AI to leveraged our understanding of where the user is, looking at the data that the user makes available through their calendar, through their email, whatever mechanisms that we ask the user to provide access to and that they grant, and then leverage as much information as the user is willing to share to give them the best possible and best personalized experience. So let's talk a little bit about 5G, and then we'll talk about edge compute. So 5G is really, more than just a big pipe. It goes much more than just about downloading big files quicker. It's also about creating an experience that's much more reliable, so that you know that you're going to have connectivity. Imagine a world where you no longer had to look at the signal bars in your phone because they weren't there anymore, right? You just know that you reach for your phone, you're going to be connected. And ultimately, my view and my vision, my goal is to see that 5G basically turns the entire world into a giant hotspot, so that we are always connected all the time, indoors and out. And once we have this ability to rely on an ecosystem, an infrastructure that is always available and always reliable and predictable, we can start to do some pretty seriously different things. So let's, for a moment, take a look at the difference between 4G and 5G. So with 4G, we focus first on latency. How long does it take for data to get from one point, the user's device, to the cloud and back again? And this round trip time is really important for lots of XR use cases, right? Especially things that might be very, very latency sensitive, like VR, where we need to be under 20 milliseconds. The other thing, of course, is data, and having not just high peak rates, but also consistently high mobile data rates, right? Because there's fixed line and there's mobile 5G. And so mobile is really what I care the most about, because it's where we get out in the real world, we're wearing glasses, and we need to be able to have that mobile connected experience. So significantly faster, consistently available bandwidth is really a big part of this. And then also density. So we have problems today when you go to a stadium or an ad hoc, a bunch of people go to a park. I remember the first Pokemon Go Fest in Dortmund in 2017, and so many people came to the park that shut all the telcos networks down because they just couldn't handle the amount of people that were trying to connect at one time. And it wasn't like they were using a lot of bandwidth individually. It's just the massive amount of people in one space. So this is something that's significantly improved with 5G. And again, it's really about creating reliability and giving people an experience that is trustworthy. So 5G is here now. We have 5G rolled out already in Germany, and it'll continue to expand. And it's going to take a while. You'll see two different sort of phases of deployment where high-density metropolitan areas will get 5G, and you'll also see a lot of rural deployment as well using low-band frequency. So this is going to work together to really start to reach out and cover the Earth with 5G connectivity. And there's a lot of aggressive, rapid deployment going on, because in most cases, the frequency auctions are over, and we're just focusing on building infrastructure as quickly as possible. And as you can see on the slide, 22 deployments in Europe alone. Lots of 5G connectivity will be available here. It is a game of race, who will get there first, who will have the highest density population coverage, and so forth. That's not important. What's important to know is that it's coming fast, and it's already available in some places. So you can start building things, you can start testing, and planning for what will be possible when you have a wider range of coverage. Let's talk about edge compute. So edge compute is also available now. So this is something that a lot of people aren't aware of. So let's talk a little bit about what edge compute is. I'm not going to get super technical here, but again, it's in a very simple way. I can tell you that edge compute is about moving the compute of the internet closer to the user to decrease the amount of time it takes for the requests for the computation to be performed from the mobile phone on the internet and bringing the results back. So as we bring the physical hardware of the internet closer to the user, the amount of time it takes, speed of light being a limiting factor, is reduced. And this is a really fundamental thing. but it's more than that. And so let me just kind of demonstrate that what it's also about is it's about putting the compute on the operator infrastructure. So it's not, there's a big data center sitting someplace and you connect to that data center through the operator. The data center processes the data and sends the result back through the operator. But we're actually putting the compute equipment into the operator infrastructure. And this is really important because it enables a lot of really interesting reliability improvements in terms of latency. We can have a more consistent range of latency. We can have more predictable availability of compute services. We can distribute data geographically closer to the user in a more intelligent way, reducing cost. In fact, cost reduction on the upstream processing of data is very valuable there, because instead of having to send, say, a live webcam feed 24 hours a day all the way to the backhaul to process that video signal to look for security incidents, we can do that data inside the operator infrastructure, processing inside the operator infrastructure, and only send to the backhaul the interesting information, the frames of video or the snippets of video or the alerts that are necessary. And that can actually reduce the overall cost of operating a service like that by a couple orders of magnitude. So it can be a real significant improvement. One of the things that we've done at Deutsche Telekom is we spun a company out a couple years ago called MobileJax. And MobileJax has released this year the world's first publicly available mobile edge network. And there are quite a number of operators that are supporting this system, and it's available today throughout all of Germany. It's not just a DT thing. It's actually something that many operators around the world will be using as a way to take their hardware infrastructure and more intelligently and performantly deploy compute function on the internet to the users. And so you can start to build applications using MobileJax today. And these applications can very easily automatically discover the compute infrastructure and find the nearest compute hardware that provides the services that your application needs, spin it up, use it, and bring the results back. And so this is a really, really powerful plan to make edge compute ubiquitously available. In many ways, like I said, making 5G turn the world into a global hotspot. The MobileJax is trying to do the same thing with edge compute, taking all of this compute infrastructure and making it generically available in the most intelligent way possible. So use cases for edge compute. What are the primary things that you would use edge compute for? Well, one of those would be to focus on synchronizing multiple player experiences, multiple person experiences. So we showed, for example, in Barcelona earlier this year, a multiplayer game that we co-developed with Niantic and Samsung, where 8 people running around playing AR dodgeball. And in that experience, the synchronizing of user data, the shooting of electronic balls at each other had to be very, very performant in order for the experience to work. Otherwise, I would move out of the way and the ball would miss me every time because it wasn't able to track me fast enough. So that's one very big thing, synchronizing experiences, shared experiences, and scaling that to handle sharing experiences with dozens and hundreds and thousands of people simultaneously. Also, rendering on the network is a very interesting value proposition, because if I want to take lightweight devices and render something complex in them, I have a limited amount of detail that I can render, a limited amount of polygons in the geometry of the 3D objects that I want to compute the render for. And I don't want to have to put all that compute hardware here. So instead, what I can do is I can use higher-end GPU-based compute on the network edge and render things that have tens of millions of polygons, and then bring that down as a video stream into the glasses. So I'm going to actually show you sort of a demonstration of some of this in a minute. Also, offloading the mapping. So spatial mapping has become really important, because we're used to saying augmented, smart glasses and augmented reality glasses are kind of the same thing. It's basically just hanging some content in front of your eyes. But what we really want to create real pervasive XR is we want to spatially place content. We want to use the real world in a tangible way as a layout mechanism for where we put content and interaction spaces in front of the user's eyes. And so this requires that we are able to map and localize the user against that map. And so we can do that compute on the devices, but the compute is very math intensive and takes a lot of GPU processing. So instead, we can actually take all of that task and put it on the network and bring the results back to the user quickly enough that they don't need to have all the compute here, which means that the battery drain doesn't have to be on my glasses and the physical form factor of the glasses can be smaller. And this is a very important part of what edge compute and 5G are going to be focusing on enabling. We can also take really complex algorithms and use them to apply things like semantically understanding the scene. So it's not just that we're going to get key point clouds or 3D meshes that describe the geometry of what we're going to looking at, but we're actually going to be able to understand what it is. This is a table, it's this size, it's made out of wood, these are movable objects in the room, this is where the doors are, this is where the windows are, that's a car, that's a dog, those are bicycles going by, and that sort of segmentation and real-time scene graph analysis is going to be super important to create pervasive experiences. I have to give a shout out to the OpenAR Cloud. I'm a founding member. This is an initiative to try to standardize the way that spatial mapping data is made available. And if you haven't already checked it out, please take a look at the openarcloud.org website. And you can download a free, really detailed document that explains a lot about what the AR cloud is, and what spatial mapping is, and what kinds of technology services and stacks are going to be part of making pervasive XR happen. So here's a demonstration of taking a video stream off of a Vuzix Blade, running this into edge compute infrastructure, calculating the key point cloud on that data, and bringing the results back. So this is just pure video upstream coming off the glasses, no compute on the glasses. So here's the result. You can see now that we have that data as the user walks around, and we're doing a camera shoot through the back of the glasses, so it's a little funky. It's able to recognize the map, the location. It's able to provide information. Those are the toilets. Here's the directions that you need to get to your gate. As we walk down the hallway, we may look to other things, and hey, there's a sale over here, so we're going to get some data that tells us that there's a 20 or 30% off sale. So this is the kind of results that you get from having this. And again, all of this work being done through edge compute. We don't have the Holy Grail XR device. I mean, I'm wearing a cool magenta Vuzix Blade. I've got lots of really nice lightweight devices, but there's a lot of trade-offs right now. So we're still not quite there, but we're getting there very quickly, a lot faster than you might think. And we don't have to wait for Apple to put some product in the market maybe next year. We have devices that we can use today that are able to be used to deliver real experiences. So I'm not going to recommend one device over the other. They're all really good, and they all have different use case value. But the point is that although we don't have the Holy Grail does everything and it's $1, we do have really good stuff that's coming to the market in the next few months, and there's going to be a lot of acceleration opportunities in terms of deploying. So let's take a look a little bit about how that looks. So we've been focused on very heavyweight devices such as the HoloLens 1 and then eventually coming out HoloLens 2, the Magic Leap Crater 1. These are big, very powerful all-in-one devices. They're also very expensive. And they're not things that anybody's going to wear walking down the street. So what we're really moving towards is the availability of tethered AR headsets. Tethered meaning that they're plugging into my mobile phone to get not only connectivity through 5G radio, but also compute and battery. And so that allows the same lightweight form factor that you see with this kind of a device, but with a more functional experience, where I have sensors and I have spatial mapping and I have spatial audio and I have more of a richer ecosystem of tech that I can use to build a pervasive experience for the user. And so these devices are going to be always on. They're going to eventually going to require that reliable connectivity. And so then I can just know that I'm going to have LTE. Now, we're going to see these devices be wired, right? So I'm going to have to plug it in to get the battery. I'm going to have to plug it in to get the display output from the phone. And I'm going to have to plug it in to get the compute function of the phone and the connectivity that the phone provides. But eventually, we're going to cut that cord. We'll use WiGig, 60 gigahertz signal. I'll come up with other approaches to transmit the data back and forth between the display device and the compute function of the phone. We'll let the phone provide the battery for its functions, and then the glasses will have to have a different solution for battery, probably a collar or some other kind of wearable battery. You can imagine a belt or something else that can be worn as part of your normal clothing and actually provides the power needed for your all-day glasses. Also, the glasses will have more efficient compute in them. And this means that we'll have new chipsets, such as the XR1 and future generations that will come from companies like Qualcomm, that'll be a lot more efficient when it comes to the way they handle camera. Because what we really need to do is have the camera on all the time in order to spatially understand where the user is. We have to let the computer vision processing constantly be occurring. And so in order to do that, we have to change the way that the camera processing is done on the chips. So that's going to become a very important aspect of how over the next couple of years we'll get to this ability to deliver an always-on experience. We can't do it today because we really can't run these glasses for 12 hours or any pair of glasses for 12 hours. We need to get it to that point. And so that'll be a key part. But also offloading the compute. So the more compute we can offload from the glasses by using Edge and 5G when we don't need it to be super low latency, we have the ability to make the devices become lighter weight, to fit a smaller form factor, to use less energy on the glasses themselves. And that will help us get to this sort of all-day pervasive tool set that we want to have for consumers. So to kind of sum up here, 5G and edge compute enable pervasive XR because edge compute provides a better shared XR experience today. We can do multiplayer sync. We can extend the visual experience with network rendering. We can control the way data is distributed at the edge. We can actually geofence data and really afford users privacy on their data while we also enable the application of that data to create a more personalized experience. 5G, because it provides inherently a low latency infrastructure, will allow us to create a tactile internet experience. So you can imagine, imagine if you will, what it was like for the first person who saw a video call. Right? They were used to picking up a telephone and dialing on a rotary dial, right? And then they went to like Disney Epcot Center and they saw the first video phone prototype, 35 years ago, and they got, wow, oh my God, I can actually see the person I'm talking to? That's amazing. So imagine in the near future that you can do more than see the other person, but maybe feel them, touch them, have a haptic high five with your kids while you're traveling on the road in another country. Having these sort of low latency experiences that are tactile are going to become a really important value proposition for consumers. And I'm really excited about the idea of volumetric video calls coming as a part of this ecosystem of services and technology stacks. Combining edge compute and 5G means that we can develop a much broader, much deeper set of use cases that run on the head-worn devices. It won't be just little pilots that we, oh, that's cool, put it on for like a minute, play a little game or something, and then take the glasses off. But it'll be really intrinsically like, wow, that's awesome, and I can't wait to sit here and use this for another couple hours. When I'm traveling, when I'm at a stadium experience, when I'm in a business meeting, when I go to a trade show and I want to meet people and I want to have computer vision help me navigate around the space, find the meeting rooms, understand who the people are. Maybe I want to link in with somebody because I'm being given permission from them to look them up based on their face, and I don't have to go through business card exchange and all the other kind of things that we do today. We can make it a more fluid, enhanced, engaged social experience. And this is really the key thing, is creating a communal interaction for users, allowing them to share that experience the same way they do on the internet today when they get into a VR environment or they're in a chat room, but do it in the real world, not just in a distracted mobile space when they're not paying attention to the real world. This allows us to have a real shared experience. And our company line is, life is for sharing, and I really believe that 5G and edge compute will enable us to create these shared life experiences on head-worn devices. So I want to play a short video. Hopefully the audio is working.
The media says 5G will provide faster internet. We say that it'll be a revolution in faster connectivity. The way we live, work, socialize will change completely. Everything will be connected. 5G will have such low latency that buffering or loading times will be a thing of the past. Bandwidth so large that the potential use cases are enormous. Driving a car will go to the next level with augmented reality navigation. Your great route on the slope will be so easy to share with your friends live. Cars will be driving autonomously on the streets, so you'll be able to spend your time in the car a little better. Drones will be saving lives by quickly transporting vital goods unaffected by traffic. Gaming will become a fully immersive experience due to augmented and virtual reality. You will enjoy various worlds and landscapes with your friends in the living room. These are just examples of the potential uses of 5G, but there are more of them.
So that ends my presentation, and I thank you for your time.
Thank you so much, Terry. That was a great speech. And I have like a little question here for you. So I'm seeing you wearing this bright magenta top, but talking about full dressing, is there any developments in underwear coming?
So it just so happens, you must have seen my LinkedIn post. So we have a website called lovemagenta.com, and I noticed that we just launched smart connected underwear. So you definitely take a look at that product. I personally draw the line at wearing magenta underwear, but I mean, maybe there's a number of people out there that would like that product. It sounds pretty cool and interesting, but I do have the magenta socks on and pants and everything else, but not the underwear right now.
And someone out of the crowd was wondering, because of the glasses, they were asking if you never had to touch a touchpad, how you moved through the slides.
So actually, I was using a teleprompter mode, so it's just sliding the text for me on a timed basis. But I could actually synchronize it. In fact, I have a device here, which is a little wrist tracking device, and I could use hand gestures and map that through Bluetooth to be interaction controls on the headset. But I didn't want to distract people by waving my hand around a lot, so I chose to not do that today.
All right, thank you so much for giving us that insight.
Cool.
Is there any more questions from the audience? Maybe yes?
So, yeah. So that's an excellent question. The question is basically, do we need to build new antennas in order to roll out 5G, and do antennas have to be spaced, roughly 100 meters apart? And the answer is no. So there are different frequency technologies being used to deploy 5G radio. What he's referring to is called millimeter wave, which is a very high frequency, low distance transmission technology. And that does require creating new antenna layouts that are using the street lamp posts or other existing infrastructure locations to position these antennas with a line of sight connection between them. But that's only going to be something that will be used probably in high density population areas over time. What you'll really be seeing globally with the rollout of 5G is going to be using existing LTE-based infrastructure. And the frequency bands that are available for 5G radio, low, mid, and high band, don't require millimeter wave antenna build-out. So we can actually use the existing towers. We'll probably add a lot more, of course, to create density, but we can use what's out there already to roll out 5G radio to start, and then we can extend that as we go on in time. In rural areas where obviously you're not going to put a new antenna every 100 meters across farmland, that's where low band frequencies will become very powerful and important because they can travel longer distances. The main trade-off would be that you don't have the same peak bandwidths with those lower frequencies that you do with the higher ones. I know Deutsche Telekom committed to something like 95% coverage of Germany by 2025, and then there's earlier deployment targets that have been expressed by other companies, and it's a constant race, right? To get the equipment set up with the new radio technology and to just distribute it in the right places at the right time. I think you'll see a burst, a pretty significant chunk fairly quickly of like say 25 to 40% coverage of population, and then it will take a fair bit of time globally to get it to the finishing point of like everybody having it. So, but the point is that I'm trying to make is that we can think ahead. We can start to imagine what happens when we do have it, and some of the friction points that we have with technology aren't there. How do we rethink and redesign our user experiences? And that's what I'm trying to inspire you to do today.
And just one question to wrap up your talk. Some of the audience asked, when are the glasses going to be available? So can you give us any insight on that?
Well, so these are custom colored Vuzix Blades glasses. You can get these today. They're just not going to be magenta. I don't know when we'll have magenta ones available, but that's to be determined. But yeah, the Vuzix Blade glasses are available now. Other products like an Real Light are very interesting. There's quite a number of devices. Again, just depends on the use case, which devices are better. So I can't really say that there's any one device that's the best for every use case or the majority of use cases. It really differs depending on what you're trying to accomplish and what kind of user experience you're trying to build.
Okay, thank you so much,
Great.
Terry.
Thank you, everybody.